Hi, welcome to pibyme Maths. This is Baiju Vasudevan. In this video, we'll be looking at May-June 2024 Pure Math 1 paper. Let's look at question number 1. The matrix A is defined by 3k for k minus 1, 2 and 6 where k is a constant. Determine the value of k for which A is singular. If a matrix is singular, the determinant value of the matrix will be equal to 0. If it is non-singular, the value will not be equal to 0. So in this case, you find the determinant value. How do we find the determinant value? Multiply the elements in the main diagonal, 3k times 6 minus the elements in the other diagonal, 2 times 4k minus 1, and equate it to 0 because the matrix is a singular matrix. So you get 18k minus 8k plus 2 is 0. 10k is minus 2. So k is going to be minus 2 over 10 or minus 1 over 5. Part B now. Given that A is non-singular, determine A inverse. Always remember, when you want to find A inverse, right, we are going to write 1 over determinant value of A times another matrix here. So the determinant value of A cannot be 0. That's why they say non-singular. If a matrix is singular, the A inverse does not exist. So okay, how do we find the A inverse? It's very simple. Okay, first I'm going to write A here. A is 3k 4k minus 1, 2, 6. 3k 4k minus 1, 2, 6. So first find determinant value of A. Is multiply the elements in the main diagonal, 3k times 6 minus 2 times 4k minus 1. 18k minus 8k is 10k plus 1. That's the determinant value. So you can straight away write A inverse is equal to 1 over the determinant value. And then you need to write a matrix here. You swap the elements in the main diagonal, 6, 3k, and then change the sign of the elements in the other diagonal. So it's going to be minus 2 minus 4k plus 1. And then divide each term by 10k plus 1, or you can just leave it like this actually. Or you can divide each term by 10k plus 1. Both are correct. Minus 2 over 10k plus 1 minus 4k plus 1 over 10k plus 1, 3k over 10k plus 1. Both are correct answer. Double I now. The matrix B is defined by P0, 0Q where P and Q are integers. State the value of P and Q when B represents an enlargement. If it's an enlargement, these two should be the same number, equal. That would be the scale factor of the enlargement. Scale factor is minus 2. So P is equal to minus 2, Q is equal to minus 2. And then part B, a reflection in the y-axis. Okay. To explain this, I'm going to show you 4 matrices and I want you to remember them all because it's not given in the data booklet. The first one is minus 1, 0, 0, 1. And the second one is, here you have positive 1, here you have negative 1. And then third and fourth one, the third one is 0, 1, 1, 0. And the fourth one is 0, minus 1, minus 1, 0. I will explain one by one. The first one is reflection in the y-axis. The reflection in the y-axis is the first one. So the second one is reflection in the x-axis. The third one is reflection in the line y is equal to x. The fourth one is reflection in the line y is equal to minus x. You have to memorize this. There are 4 transformations you need to remember. And then there is fifth one, which is A0, 0B. That's a stretching by scale factor A parallel to x-axis, stretching by scale factor B parallel to y-axis. And if A and B are same, that's enlargement. These are all the things in Further Pure Math 1 you should remember. Okay, so in the question says reflection in the y-axis, that's basically the first one, right? So it has to be minus 1 and 1. So the value of P is, back to the question, value of P is minus 1, Q is positive. That's all. Just a 2-mark question. Question number 2 now. Show that P is negative 87 where Z is equal to 3 is a root of this equation. If Z is equal to 3 is a root, if you replace Z by 3 here, you will get 0. That means f of 3 will be 0. So that's 3 cube minus 13 times 3 square, 59 times 3 plus P is 0. And then you don't need to show any other step. You can straight away write P is equal to minus 87. But it's good to verify always. 3 cube is 27 minus 13 times 3 square plus 59 times 3 is 87, goes to the other side, minus 87. That's all. Just a 2-mark question. Part B. Use algebra to determine the other roots of f of z equals 0. Give your answer in simplest form. Okay. You already know z is equal to 3 is a root. So if you put the 3 other side, z minus 3 is a factor of this function. So you can use long division method or comparing the coefficient method. So I'm going to show you the comparing the coefficient method. So when you divide the f of x by z minus 3, let's say you write f of z here and then z minus 3 here, and you apply the long division method, the remainder is going to be 0. You will get a quadratic function here. Because when you multiply z times z square is z cube. So you will get a quadratic. So when you multiply these two, multiplication of divisor and quotient will give you the function, right? So instead of using long division method, I'm going to show you the comparing the coefficient method. Write the f of z first. Z cube minus 13 z square plus 59 z plus p is minus 87 is equal to z minus 3 times, write a quadratic, az square plus bz plus c. And I'm going to compare the coefficient of x square, z cube on both sides of the equation. Here it's 1. Here after opening the bracket it's going to be ax cube. So 1 is equal to a. Compare the coefficient of z square now. Here the coefficient is minus 13, negative 13. On the right hand side you will have z square when you multiply these two and when you multiply these two. So it's going to be minus 3a plus b. You know, a is 1, sub in here, minus 3 goes to the other side, plus 3, b is negative 10. And then you can also sub in any value for z. I'm going to sub in z is 0. So these things will be 0. Minus 87 is equal to, this is 0, so minus 3. Here these two become 0 times c. So c is minus 87 over minus 3. 29. We got the values of a, b, c. So we are going to sub in the values of a, b, c here and factorize the quadratic and find the solutions. So we can write the function as a z square. We know a is 1 plus bz plus c. b is minus 10z plus 29. So when you equate it to 0 to find the roots, you will get z minus 3 is 0. That's one of the root which is given in the question already. And z square minus 10z plus 29 is 0. So z is minus b plus or minus square root of b square minus 4ac over 2a. And then straight away use your calculator to get the values. 1, negative 10, 29. Or two complex roots, 5 plus 2i, 5 minus 2i, 5 plus 2i, 5 minus 2i. So we got all the three roots already. Part C now. On an organ diagram, they want us to plot all these points, P, Q, R, S. P is represented by z is equal to 3. That means the point P is, there is no imaginary part, only real part. The other roots, we got two other roots, 5 plus or minus 2i. So Q of 5 plus 2i, R of 5 minus 2i. Or you can swap these two, doesn't matter. Z is equal to 9 is represented by point S. So there is no imaginary part. We need to plot all these points now. So let me draw the real and the imaginary axis first. Always label the axis. This is real axis. This is imaginary axis, origin. The first one is 3, 0. So let's put P here. You can mention the coordinates 3, 0. And then R is 5, 2. Q is 5, 2. Let's say Q is here. 5 plus 2i. You can just put Q and 5 plus 2i. You can write it this way also. R will be the reflection here. 5 minus 2i. S is minus 9, 0. You can put PS 3 here. That's all. Just a one more question. Now they want us to find the perimeter of the quadrilateral PQRS. So I'm going to copy the figure here. This organ diagram. They want us to find the perimeter of PQRS. PQSR. SR. They want us to find the perimeter of this. So we need to find the distance SQ, which will be the same as the distance SR. And then you need to find this distance, which will be the same as this distance. Add all the distances, lengths. That will be the perimeter. Okay. So we are going to take it as a point S of minus 90, Q of 5. So the distance SQ is square root of y2 minus y1 the whole square plus x2 minus x1 the whole square. Get this value. And then the distance PQ. The point P is 3, 0. So PQ is x2 minus x1 the whole square plus y2 minus y1 the whole square, x2 minus x1 the whole square. And then we write the perimeter finally. Let's calculate this first. This one is 2 square plus 14 square. 2 square plus 14 square is 10 root 2. Okay. Here it's going to be 2 square plus 2 square is 8. Square root of 8 is 2 root 2. So therefore perimeter is equal to 2 times 10 root 2, because the length of this is 10 root 2. The length of this is also 10 root 2. So you multiply by 2 plus 2 times 2 root 2. That's 20 plus 4, 24 root 2. They want us to give the answer as a simplified surd. 24 root 2 is the answer. Question number 3. We have f of x given. The function f of x equals 0 has a root alpha in the interval 0.25 and 1. Use linear interpolation once on this interval to determine an approximation to alpha. Okay, first thing first, you need to find f of 0.25, which is 0.25 cube minus 5 square root of 0.25, 4 times 0.25 plus 7, get this value. And find f of 1, which is 1 cube minus 5 root of 1 minus 4 times 1 plus 7, get this value also. That's what we are going to do first. 0.25. Okay, first let me find 1 cube minus 5 square root of 1 minus 4 times 1. Even though we know 4 times 1 is 4, 5 square root of 1 is 5. I'm just typing this, so later I can come back and change all the 1 to 0.25 plus 7. So we got negative 1 here. Now I'm gonna change all the 1s to 0.25. 5 square root of 0.25, 4 times 0.25 plus 7. 3.515, 625. Okay, so when you calculate, if you get so many decimals, immediately store the value as A or B. I'll show you how. Let's say this number has so many decimals. Immediately store it as A. That will make your life easier. And just use your pencil to put a little reference here, A. And let's say this minus 1 is a number with so many decimal also. You store that as B also. Since it's minus 1 whole number, you don't need to store it. Okay. Now, so listen to me carefully. We have this 0.25 here, 1 here on the x-axis. Okay, when you sub in 0.25, you got a positive value, so it's on the y-axis positive side, right? This is positive side. Okay, when you sub in 1, you get negative 1, right? Okay, I'm gonna draw a line here. So we are going to assume that this is alpha, the root between these two. Okay, and we are going to use the method, the similar triangle method. Okay, what is that method? This length divided by this length. That means alpha minus 0.25 divided by 1 minus alpha. That's the length, right? Length of these two line segments, correct? Will be equal to this length. This length will be this, right? 3.515625 divided by this length. The value of the function is minus 1, but the length is positive 1. You cannot take it as a negative, right? Now you need to make alpha as a subject. Cross multiply, make alpha as a subject. Okay, so I want to explain one more thing here. Let's say here you have so many decimals. Instead of writing this dot dot dot, you can also write it as f of 0.25. You can continue with this and finally sub in the value of f of 0.25. But in this case, it has only few decimals, so I'm going to write the actual value, 3.515625. And we are going to cross multiply. So alpha minus 0.25 is 3.515625 minus 3.515625 alpha. And collect all the terms involving alpha to the same side, numbers to the other side, and make alpha as a subject. So I have copied the whole thing here. So I'm going to move this here. So alpha plus this will be 4.515625. Alpha is equal to this plus this. I have stored the value as A already. So instead of the value, typing the value, you can use A plus 0.25. 3.76525. So alpha is equal to this divided by 4.5152625. 0.8339, but look at the question, they want the answer to 3 decimal place. So 0.834, that's the value of alpha. That's all. They just want us to use the interpolation method only once. So that's the answer. Let's move on to part B now. The equation f of x equals 0 has another root all beta in the interval this. Determine, first find f dash of x. Okay. We know f of x is equal to, write the function first, x cubed plus 5 root x. X cubed plus 5x power half minus 4x plus 7 minus 4x plus 7. So when you differentiate it, it's going to be 3x square plus 5 times half x power half minus 1 minus 4. That's all. That's the differentiation. Just 2 more questions. But this was minus 5 root x, right? So it should be minus 5 over 2. Now the next part C, hence use Newton-Raphson process once and using this as a first approximation and find the second approximation. This is a Newton-Raphson approximation. xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is given in your data booklet. So if they want you to find x1, it's x0 minus f of x0 divided by f dash of x0. x0 is 1.75, so 1.75 minus, you need to sub in 1.75 into the actual function, which is x cubed minus 5 root of x minus 4x plus 7 divided by, you sub in the value into the first derivative of the function, which is 3x square. So 3x square minus 5 over 2 x power minus half minus 4. Get the value, round it to 3 decimal place, that's all. So therefore x1 is equal to, so I'm going to calculate this now. Okay, 1.75 minus, on top it's 1.75 cubed minus 5 square root of 1.75, bring out the cursor, minus 4x, x is 1.75 plus 7 divided by f dash of 1.75, which is 3 times x square, 1.75 square, minus 5 over 2, which is 2.5 times 1.75 to the power minus half, minus 0.5 minus 4, 2.13057, 2.13057 dot dot dot. So it's basically beta. So beta is equal to, they want the answer to 3 decimal place, 2.131. That's the answer. Question number 4. The complex number z is defined by minus 3 plus 4i. Determine this. Let's find z square minus 3 first. Z square is z times z minus 3. So when you multiply, it's like a plus b whole square, a square, or just take minus 3, multiply both. Take minus 3, multiply both, you will get 9 minus 12y. Take 4i, multiply both, you will get minus 12y plus 16i square minus 3. So it's basically 9 minus 3 is 6 minus 24i. I square is negative 1, so minus 16. You'll get minus 6 minus 16 is minus 10 minus 24i. So when they say modulus of a complex number, z square minus 3 is a complex number, you can just take square root of 10 square plus 24 square. So square root of 10 square plus 24 square. 26, that's all. So 3 mark question. Part B now, express 50 over z star. Z star is a conjugate of z. We know z is minus 3 plus 4i. So the conjugate of z would be minus 3. You need to change the sign of the imaginary part. So when they say 50 over z star, conjugate of z, 50 over minus 3 minus 4i, they want us to write it in this form. So apply this method, take the conjugate of this, multiply and divide. So on top you are going to get 50 times minus 3 plus 4i. At the bottom, a plus b times a minus b is a square minus b square. It's going to be 9 minus 16 I square. I square is negative 1, so you're going to get 9 plus 16, which is 25 at the bottom. And 25, 50 can be cancelled, so you're going to get 2 times, well, you can write one more step, 50 times minus 3 plus 4i divided by 9 plus 16. So if you cancel 50 and 25, you're going to get 2 times minus 3 plus 4i. They want us to write the answer in this format. We know z is minus 3 plus 4i. So this is basically 2z. That's all. Part C now. Hence find the value of argument of this. So we need to find the argument of this is basically 2z, right? 2z are minus 6 plus 8i. Minus 6 plus 8i. To find this, first find tan inverse of y over x. Y over x. Y is the imaginary part, x is the real part. Leave the sign and all, take it as positive. And then think about it, the value of x is negative, y is positive. So definitely in the Argand diagram, this will be in here, right? Where x is negative 6, y is positive 8, right? So to find the argument, to find this is argument of this complex number. You find theta and you put pi minus theta. Right. Theta is tan inverse of 8 over 6 in radians. So use your calculator in radians. Tan inverse of 8 over 6, 0.927 ... Therefore argument of 50 over z star is equal to pi minus this value, pi minus the answer. And they want you to round it to 2 significant figure, 2.21 radians. That's the final answer.